we are going to cover some of the guiding principles for unit testing in JUnit. So all of your tests should follow these three principles. First is they should be repeatable. Repeatable means you should be able to run those tests multiple times, and if you have not changed your code, all the tests should produce the same results. And they should be independent. Independent means you should be able to run the tests in any order. They should not have any dependency on each other. And they should not depend on data which is based on the environment or the machine or the operating system. So every test should be independent and they should be thorough. You should cover all possible use case scenarios. So let's cover each of these. So test method should not depend on any test data in the environment in which it is running, like the machine on which it is running, the operating system on which it is running. Okay, and each test should set up or arrange its own data. So test should not. So for the test to be repeatable, if all the data is within the test itself, if each test has a responsibility to create its own data, the test will be repeatable. And if a set of tests needs some common data, you can create some utility classes which are called as data helper classes. You can set up the data using these helper classes and reuse them among the tests. And I said a test method should be independent. It should follow the 3 A's in this order. They are called as arrange, act and assert. Arrange means setting up your data, and in JUnit you do it in the setup method. Act means you invoke the method that you want to test, and after acting you want to check the state of the object by using assert statements. So in the assert statement you compare the expected values with the actual values, and if the assert passes, that means your test has passed. If the assert fails, the test has failed. An important thing to know is a test method should test for a single logical outcome. That means it should have a single logical assert. A logical assert could be, in some cases, could map to multiple physical asserts, but all those physical asserts should test the state of a single object, not multiple objects. So the test method should change the state of a single object. And we should avoid doing asserts inside the setup. If the data setup is not correct, you should not do asserts and make the test fail. If the data setup is not proper, let it throw exceptions and let the test fail. Don't do asserts in the setup. And do not do any more actions after the assert statement. Typically you should have a single assert statement, but sometimes you can have multiple assert statements which all test the state of the same object. And after doing the assert, don't do any more actions. So the test should test for a specific scenario. So let's come to the scenarios. So every test I said should be thorough. So it should not just aim for testing the happy path scenario. You should also test for scenarios where the actions will throw exceptions. Okay, and you should also test for scenarios using data at the boundary conditions. Okay, and let's look at the naming conventions for the test. So the test method names should be meaningful and reflect the use case scenario that you're testing. And it is okay to use long names. The important thing is the test name should express a fact of life or some workflow and the expected output. So the test name should include the expected input and the expected result. So let's look at an example. So it is called as a paradigm of given a method, when the state is something, then you get this output. So given maps to the method name, when means your input or the state of the object when you invoke that method. So when maps to your inputs or the state of the object that is being, or the state in which the object is set up before you invoke the method. So it maps to either the input or the state of the object which is both more or less the same, and then maps to the expected behavior or the output. So if you look at some examples here, let's say I have a method called sum. If I'm adding two negative values, what should be my output? I would expect that it should return a negative value. So I will name this test for the method sum for the scenario of adding two negative numbers, that it should return a negative value. So I call this test as sum underscore negative values underscore returns negative value. Then I have a scenario where I test for adding two positive values. I should get a positive value. And let's say I'm doing a divide, and if the second parameter is 0, then I should get an exception. So let's look at an example now. So here I have a class called myString. Okay. What I am doing here is I am creating a method called substring, and if you look at the JDK API for substring, if you pass a begin index, it will give you the string from that point onwards. But if you pass this begin index as a negative number, then it throws an index out of bound exception. And if you pass an index which is greater than the length of the string, then also it throws an index out of bound exception. So what I want to do in this class is to modify the semantics of the substring method, where if the begin index is more than the length, I just want to return the whole string. Normally it would throw an index out of bound exception. For the sake of this example, where I want to show different use case scenarios, I am making it return the entire string if the begin index is greater than the length of the string. For all other cases, like if you pass a negative index, it will still throw the index out of bound exception. And for the case where the begin index is between 0 and the length of the string, it will behave normally. The only thing that I have changed is if the begin index is more than the length of the string, I return the whole string instead of throwing an index out of bound exception. So now my method substring will behave like the regular string substring, except that when the length is more than when the begin index is more than the length of the string, it will return the whole string. But if the begin index is negative, it will still throw an index out of bound exception. And when the begin index is between 0 and the length of the string, it will behave as it is. Okay. So let's look at an example here. So I have a string called myString called hello. So the constructor of this will initialize the string that I'm storing internally. So I'm passing hello. So when I pass the index 10, since 10 is more than the length of the string, which is 5, it should still return the whole string hello. That's one thing. So let's run this program. So if you see here, if I pass the begin index as 10, it is returning hello. If I pass the begin index of 1, so the string starts from 0, which is H, 1 is E, 2 is L, 3 is L, 4 is O. So it is printing from index 1, which is ELLO. But now, and then when I'm passing a begin index less than 0, like -1, it is behaving the same way as a string would behave. That is, it will throw an index out of bound exception. Now I want to write a test case to cover all these three scenarios. So this one, when I pass index 1, that is a happy path scenario. Whereas when I pass index 10, that is like a boundary condition. Or if I pass an index 5 or 6 or whatever. And then if I pass -1, that is, you are expecting an exception to be thrown. So let's look at all these cases. So here I'm naming this, look at how my naming convention is. This is the name of the method that I'm testing, substring. And what is the use case scenario here? Begin index within range. And what is the expected output? Expected same substring as string. So when I pass the begin index as 2, it will get me LLO, which is starting from the index 2 in hello, in the word hello. Okay. And the next case I have is I pass a negative value. So like the substring of the string class, my class should also throw an index out of bound exception. And I put that in the @test expected equal to index out of bound exception dot class. So I'm now testing for exceptions that have been declared within my method. And the last case I have is, and look at the naming convention of this one, sorry. The begin index is negative. So I'm expecting an index out of bound exception. And this is my boundary condition where I'm testing that the begin index is longer than the length of the string. Then I expect the output as the whole string. So if I pass 5, okay, I should get hello. So let me run this program. Let me run this test now. Run as JUnit test. So the first two have passed and this one failed. So let's see what the failure here is. Expected was hello, but as you can see the expected is empty. So it looks like there is a bug in my code. So what I'm going to do is I'll try to go and fix the code. Here I'm passing the length of the string as 5, which is a boundary condition. So for hello, the length of the string is 5, right? HELLO. So if I go to my string and look at this here, I'm checking whether the begin index is more than the length of the string. So I missed the boundary condition which is equal to the length of the string. So all I have to do is put the begin index should be greater than or equal to the length of the string, and I'll run my test case again. Right click there and say run. Now all my test cases are passing. So this example shows how you test for a happy path scenario, then for a scenario where you expect an exception to be thrown, and a scenario where you're testing for data at boundary conditions. Okay, yeah, try out this program, and in the future when you write tests, make sure that you cover all these different kinds of scenarios.